be delivered by Pavel Petrovič. He's an assistant professor from Comenius University. And the title is Summer League, Supporting FLL Competition.
Can you hear me? Thank you. So it's a pleasure to be here, and I have to thank all the groups yesterday who were discussing all the issues about constructionism, because most of them asked what is constructionism. I hope to give you one of the answers to show you what is constructionism and what I think is constructionism in action. So the topic of the talk is a report about the competition that we run for 3 years in Slovakia. And the competition is a support for children who participate in First Lego League. Some of you may know what is First Lego League. If not, I will tell you some more details about that. And the First Lego League runs in fall, and in the spring we would like to give some more activities to the children. Of course, there are some other contests they join, but many of them don't, and we would like them to get ready for the next season. I wrote this article together with my colleague Richard. He's from a different university, but on the opposite side of the same street. He's from the Slovak University of Technology. I'm from the Comenius University. I work at the Department of, as you mentioned, Applied Informatics. And you see Richard is the person second from the left with his students. This is a picture where they won the European round of free-scale challenge. Those are the robots that run on a racing track. Richard is also organizing Istrobot. It's the main event of our Robotica.sk association. Annually, about almost 100 robots register for this competition and come and compete in different categories. Those are line follower robots on the top left, with some bridge, some fence. There is an obstacle to go around. Line can be interrupted. It can be split into 2 different lanes which have different length. Then there is the traditional micro-mouse contest, where the robot navigates in a maze and needs to find the destination in the shortest possible time. So it can also create a map of this maze and then return back to the start and go as fast as possible. The third category is about, it's called Ketchup House, and there are cans. And the robots, 2 robots at the same time, compete about acquiring the cans. And there are also flying robots. And there is a special category on free ride, where the robots of all kinds are presented. I'm also involved in many competitions. And you see here a picture from some young creator contest. And I'm also coaching a team of kids in the primary and secondary school. And in the demo, I showed you my robots that I built for the freshmen. So I involved with robots and robot contests for more than 15 years. Here are some examples. It's a FLL contest, and this is probably the most talented Slovak team for RoboCup Junior. Then there is our students judging the robot challenge, one of the categories, and my master student showing some robot that can do pick and place operations with bricks, because it has a stereo vision and the algorithms that are required for this to work. I could not resist to insert this picture from the robot tour contest, where we participate with our outdoor robot. This is an outdoor delivery challenge, and it's organized by Czech people. So the goal is to deliver a large bucket of beer to a specified destination in a park. And there is also a picture from one of those contests that we add to RoboCup Junior. We add a special contest called Construction, or category Construction, where the students bring their set to the competition site, and they don't know the task in advance. And we give them about 5 hours to build and program their robots, and then after these 5 hours, they present them and collect the points. And it's very nice because you don't need to work 3 months in advance to build some particular special robot. You just come there, and also we filter out the influence of the coaches, because coaches cannot help them in any way, which is not the case in FLL or RoboCup Junior. Here are some more pictures how it can look like in Robot Tour. Sometimes it gets rainy, and then we need to do some adjustments to our robot. Okay, but back to the topic. So we would like to support First LEGO League. What is First LEGO League? First LEGO League is a competition which runs every year, already since 1998. It was started by FIRST, that's an association in the United States. Now there are about more than 200,000 children in the whole world, in more than 70 countries. In Slovakia, we started, when I met Peter from the company delivering Lego robots at this conference in Bratislava in 2007, we made an agreement, let's do FLL in Slovakia. And we've been quite lucky to find some nice sponsors. So currently we have about 76 teams in Slovakia, and they are competing in 6 different tournaments. We are adding a new tournament next year. This competition is special in that way that it's not about robots only. The teams need to do more. They need to come up with some presentation of a research project that they have done through the preparation period of at least 8 weeks. So they need to find some particular problem that they would like to address and come up with an innovative solution. And so they learn to be researchers. And then they also need to present it in 5-minute presentation at the contest site. And it is also special that it is also focused on teamwork. There is a teamwork category, and the kids will get a special task where they are observed how well they know each other, how well they cooperate, how well they can communicate, know their strong features, and can build on ideas of each other. And back to all kinds of contests. I tried to summarize different properties that we can look at from different types of perspectives. So one thing is how much time is required for preparation. For instance, the construction category requires almost no preparation. FLL requires maybe several weeks of time. RoboCup Junior typically requires 3 years to be really successful. Then the different competitions have different requirement on external help. For instance, in RoboCup Junior, the teams are really dependent on knowing someone who can help them with the electronics, who can help them with creating the design of the robot base. And this is not accessible in the rural areas. It is not accessible to anybody. So there is a big difference about the starting line that the kids have. In contrast, for instance, FLL has the same starting line because it uses the same platform. Recidivism is that how much the same task repeats again and again. In RoboCup Junior, you have the same task every year. The rules change a little bit from year to year, but in order to succeed, the team really needs to work for maybe 4 or 5 years to be successful. Whereas in FLL competition, it is typical situation that the novice wins. The novice teams can win too, because children are building Lego from the early childhood, and the programming part is not that difficult. It's more about creativity and what they can do to solve the tasks that are new every year. Every year as a new set of tasks. Then I look at the amount of creativity. Again, if you look at the RoboCup Junior, the solutions are already quite known. You need to have a dribbler, you need to have omnidirectional wheels, you need to have some fast-moving robot. So there is not so much creativity. Of course, still a lot of, but it's a different story when you look at FLL competition, when there are completely new tasks every year. Now there is a teamwork focus. You have RoboCup Junior also requires teams of at least 2 people. FLL are teams from 3 to 10. And there is a special category in FLL for teamwork, which is very unique. But there are competitions where you go and take your own robot and present it. So there is no teamwork focus. And the narrow focus means that there are some competitions where you only have to do one task. To participate, you solve one task, which is more complex, but you are focused narrow, or you have many different tasks, maybe 15 to 20. That is the case in FLL every year. Standard platform and the expenses of teams and organizers. So why is FLL so successful? I see these points. First is the common platform, then new tasks every year, so the novice team can be very successful and stimulates teamwork, and it has a broader scope because of the research project. So it is easy to attract girls, for instance. They start working more on the side of the research project, but then they also learn a little bit about robots. So it's a nice trajectory for the girls to get into robotics. And FLL is quite independent from academia, which is, in a way, we should not say this, but it's true. It's a positive point, because RoboCup Junior is dependent it's designed by people from academia, and it's organized in a quite not good way. The rules for this year contest were only published in the middle of January, just like 2 weeks ago, but the kids need to work on it since September, and only in January they decided, oh, are we going to use the infrared ball, or are we going to use the orange ball, and then you need to use camera. So they announced in January, but the national contests are in March, which is really bad practice. And they do it again every year. That's because these are people from academia. FLL is organized professionally by independent associations, and they really try to make sure that everything is in very good time, early announced and properly organized. And there is a relatively short period of time to prepare for the contest, several weeks, and during this time, kids, together with their coaches, work very intensely. And they have to focus, and then they have time to maybe refresh, get new inspiration for another season. And that's where we come in. But I will show you more. Where is the problem with FLL? Well, also the standard platform is a little bit problem. All the teams complain about it. Oh, we would like to use the text language instead of the graphical language. But we always say no. And it's also very demanding on coaches. And there is a frustration. I say frustration guaranteed, because this is a single-day event. You come to the tournament, and you know, in robots, there are so many things that can break. And if you take 15 tasks, and every task has the probability of 70% of succeeding. So it works in 7 out of 10 cases, which is quite good. But the chance that all of them will work out is less than 0.5%. So it's 99.5% that some of these 15 tasks will fail, which is practically totally sure. So then the kids are always disappointed. It's like frustration guaranteed. So, and it's difficult for coaches to prepare the kids for this to happen. So we see some unusual potential. There is a lot of time during the year when the teams stop working. They just stop working and wait until the next season will start again. Some of them go to different contests, but not many. And the coaches told us, oh, maybe you can come up with some new contests for them during this time, or some preparation, something. So we invented the Summer League. I was going to show you the video of FLL, just to get you some idea how FLL looks like. This is a view from above. There are always two tables next to each other. In the corner, there is something called base, where teams can rebuild their robots. They can attach new attachments. And they have a lot of tasks to solve. There are many different Lego models bound to the table. And you have only 2.5 minutes to solve the complete mission. So in this case, you see that they combine a lot of it. First, they release some waves, then they pick up the green motorcycle and another loop, and they try to lift the house, and they also take the blue truck back to the base where they can take everything and work on a different mission. So these are children from 10 to 16 years. The robots are completely autonomous. They are pre-programmed, and they have about 2-3 months to work on this. So this is FLL. Okay, so about our summer league. We keep the same rules as in FLL, which means we have children 10 to 16 years. We are also open to teams that are not FLL. They don't have to register to FLL. They work in the clubs at home. They solve the task that we publish. And we publish a task about every 2 weeks. They have 3 weeks to complete it. And then they use our web application that was written by our students. So it's easier for us. In the first year, I had to do it manually. I got emails, and then I created HTML files and put it on the web. But then I thought, oh, that's too much work. And then I asked our students to write a web application, which is used both for preparing the tasks, evaluating them, and of course, submitting by the teams. So the solution should contain a photo of the team, photo of the robot, the program that can be downloaded, and a video that is uploaded to YouTube in the style of unlisted, so other teams cannot see it before the deadline, even though it is already on YouTube. And all the submissions become available publicly after the deadline, when nobody else can submit anything else. And the main point that we like about this competition is that after working on this particular task for 2 weeks, or 3 weeks maybe sometimes, they come to the site and look at the solutions of everybody else. And they learn extremely a lot, because you learn when you have some circuitry to bind the new material onto. And after they have been intensely working on coming with the best solution they can make, and they see how this can be solved in a different way, they learn extremely a lot. And every solution is different. It's extreme amount of creativity. So I will show you now some videos from several example tasks. We already run 3 complete years. We start the new season probably today, and we are opening it up for the international audience, international participation. Until now it was only Slovak. So the new application, which was completely redesigned in a new student project, is supports also English and Slovak. And you can find it in the website of FLL, but I don't think I have internet here. But if you have that fll.sk, it's possible to find it there. I just published it yesterday. Okay, so go to videos maybe. This is the first task. It's a robot that is supposed to spread fertilizer over some golf course. And the task is to create some mechanism that can release a little Lego parts over time, systematically over some area. It is also using a sensor to detect the borders of the field. And it needs to navigate successfully through this field. In this task, the teams were supposed to construct a robot that can water plants. A family went to a holiday and they need their plants to be watered, so they need a robot to help them. And there is a dog that can move the plants overnight, so the robot is supposed to find them. It needs to use a sensor to locate where are the plants and come exactly there and give them water. Sorry about the quality of some videos because it's recorded by the teams. And then after a while, it's the second day after the plants were moved, and the robot still successfully finds them and gives them some water. It will use the sensor always to turn and find where it is. This is my favorite task. It is a skier task. This robot is a skier, and it's placed on a tilted plane, and it is supposed to find the direction uphill, and then turn and slide downhill. And they are not allowed to use gyroscopes or inclinometers, accelerometers, or anything like that. They need to come up with their own design. So in this case, what they did is, maybe we play again somewhere this way. They are measuring the distance from this moving plate to the ultrasonic sensor, and when it is shortest, then the robot knows now I'm facing uphill. So they need to come up with this idea. It's, I think, very constructionist. Here is another solution. There is a robot that has particular type of caterpillars, and it turns or it moves front and back depending on which side it is. So then it presses the touch sensor that it has on the back, and then it knows that, oh, now I'm facing uphill. This is another solution of the time, but I put it here only because it's very funny what the robot does at the top. So it's really a skier. But this is very special. You see the green ball, and there is a round area, and there is a sensor that can detect this ball. So while the robot is turning, the ball is rotating around the circumference of the circle, and when it is at the proper position where the robot is facing up, it knows now I should go up. We would never think about this idea, and it was very rewarding to us to see this kind of solution. I don't know how much time I have. Some teams make very nice videos. 5 minutes, yeah, that should do. So they also show how they build the robot, how they prepare, how they program it. They can move it a bit faster. Prepare the track. In this case, the robot is moving. It's a car after another car which is slow, and it needs to take over. So it needs to first come closer and decrease the speed and wait until there will be the possibility to go around, because when the line is full, you cannot take over. When the line is striped, you can take over. Programming part, and now the test. The vehicle in front is slow, and the robot is a bit faster. So when it comes closer, it has to regulate the speed and wait, and now it can take over. That's it. Another of the same. They make it a little bit funny preparation. They are running. Now the action. So all of these tasks are in not very big complexity. You can solve them in 1 or 2 meetings in the robot club or in the school, and really get concentrated and
get the party started. Mad shout.
they like to make some fun. Some more tasks. Again, this team, they have really the best videos. In this case, they were supposed to make a secret treasure where you can store your things and access them only using a special card with a particular black and white pattern. So the machine should learn the pattern first. And then if you present the same card, it should open the treasure. If you present a different card, it should not open it. And in this case, there were again many solutions. Some of them, in this case, they convert to binary. They make 16 readings of black and white, and then they get some binary number and encode it in this way. Some other teams would be recording the time intervals or rotations it requires to move from the black to white area, and then saved this whole pattern to a file, and then compare it, read the new card and compare these 2 files and see if the difference is above certain threshold. And the teams are allowed to make it more simple, to simplify the task, but then they don't get the full score, but we are still happy that they at least submit something. So this was the wrongly inserted card. So the person who wanted to break in was has left unsatisfied, and now is the proper card. Sometimes we try to give them, there is another solution which records it to the files. Yep. So it measures the time interval, but you can imagine. This is another task where, which was focused on mechanics a little bit. The goal was to make a robot that can swing. And it should start swinging, do it for a while, and then stop swinging. And the difficulty is in the time pattern of the movements, because it changes while you move in the sequence. And in this case, they have a light sensor on top, which detects the intensity of reflected light from this roof. And in this way, it knows in which phase it is. One more of the sort. These are girls from Košice, from eastern Slovakia, and they have thought that we cannot make this pattern, so let's learn it. So in the first trial, they use a touch sensor and make the robot swing manually, but it is recording the pattern into the file, and then later on, they just disconnect the sensor and the robot moves from this pattern. There is a small problem because there is the wire of NXT robot is a little bit thick, so it influences the swinging a little bit, so it's not as perfect movement, but it still works. So now it has recorded the timing and performs the moves. Just stop me when it has to be. Oh, this is also a swinging robot. Also how they build it. Sorry for the stroboscope. So here they use the infrared sensor at the top, I think, or maybe not. They just wanted to use it, but then they just come up with some time. It's a small thing, so it's probably just a regular timing in this case. And like to give in the middle of the season a special task which is focused on creativity. We give a wide topic. In this case, it was fine art, and the teams are supposed to do anything they like. So they have made different robots, one that can paint. Then they used it to paint a T-shirt. They first tried on a paper, find their lovely pattern, then they use some colors to paint it, but then they put a T-shirt and they create their own T-shirt with a robot. And here it is. Of course, manual work improves it a little bit, but it's also made of, here they use some pencils, but again improve it manually by in this way. And of course some smiling, that's it. So this was very funny because there were a lot of great creative designs. In this case, the team created a robot that can, I think it's somewhere in the middle. You see it has a light sensor which can also illuminate different colors, and it can rotate, and they put it into a dark room and make a long exposition with a photo camera, and they create very interesting pictures. This is the setup room. They turn off the light, the robot rotates with the lamp, and then it looks like this. And at the end, this is the outcome. I think I should stop at some point of time. If you like, all these videos are available online. Just come to our website. So what we have done is we have made 30 tasks with solutions which you can use in your robot clubs or anybody else. There is a task description and a solution, programs, many different solutions. Oh, sorry. And of course, the main goal is to prepare the kids for FLL, but we figured out that it's even more interesting than FLL for us from the constructionist point of view. It's free and easy to join. There is emphasis on learning and creativity. There are no frustrations from the events at the tournament because you can take your time to run it even 5 times and record the video. And we maximize sharing. It's really focused on sharing, and it's an instance of constructionism online. So I hope I answered your questions about what is constructionism from yesterday. Now you know, and you can all go home and join us. Thank you very much.
Okay, thank you. Do you have any questions from the audience? Yes, Cynthia.
I could not hear you. Could you please repeat?
Can you use the microphone, please?
Yeah, the girls are there. I cannot show you anymore, but some of the videos contain the girls also, yes. And plenty of girls. In fact, FLL is really proud on having a large percentage of girls in the teams because, as I mentioned earlier, there is this research project which is a nice path into the robotics also for girls. The teams need to be 3 to 10 people in FLL, and then they need to prepare a research presentation, which is really something that girls like to do more than boys, so they join in the team, but at the same time they learn a little bit about robotics. So it's a nice path for the girls into. There is about 30% of girls overall in FLL, which is much more than other technology-based contests.
More questions? Okay, well, thank you very much.